What's up everyone? This is Josh. Welcome back to our video tutorial series on beginning iOS unit and UI testing. In this video, you learn about the basics of setting up a unit test target, importing your app's target, and writing a few simple unit tests. We'll be adding tests to Sam's Stack Review app throughout the entire video tutorial series. This is a master detail style app, which shows a list of pancake houses. When you tap one, you'll see its name, rating, details, and map. Tests in iOS run in a separate target from your main app. This means Swift's modules and namespacing come into effect. Normally, you can only access the public parts of a different module. However, Swift adds a special import for use in testing, @testable import. This gives you access to both the internal and the public components for the imported module. This means you'll be able to access your app's code as if your tests were part of the same target. You still won't be able to access the private components, however, which are intended to be accessible only in their limited scopes. Your test target will be composed of several test classes. A test class is a subclass of Xcode and contains multiple test methods, each of which must begin with the word test. Just like your production code, it's important for your test code to be as simple as possible and do just one thing. Each test method should test one unit of work, whatever this may mean for your app. Often, this usually means a single test will have one test assertion. However, you can have more than one test assertion if it makes sense for your use case. You're allowed to have other helper methods too, and you will actually create these in the demo. But only the methods that begin with the word test will be executed automatically. When you run a test, here's what happens. First, the test runner looks for the method setup, which you're expected to use to perform test method setup. Next, the test runner executes one of the test methods that begin with the word test. Test order is not guaranteed, so it's important to make sure your tests are designed to be independent from one another. After the test is completed, whether it passed or failed, that is, as long as your unit test didn't actually crash while executing, the test runner calls teardown, where you're expected to perform test teardown. Lastly, the test runner checks if there's any other methods that begin with the word test. If so, it executes another test method, again calling setup before the test method is called, and teardown after it completes. Thereby, both setup and teardown are called once for each test method. As you might imagine, you can easily waste all day writing useless, repetitive tests. So it's important to define what makes a test useful. A useful test meets 3 criteria. First, the test must be able to fail. If a test can't ever fail, it's worthless and you should delete it. Second, the test must be able to pass. If a test has impossible criteria, for example, asserting that 1 equals 2, it's likewise worthless, and again, you should delete it. Lastly, the test must be refactored and kept simple. This is important to eliminate redundant tests, repeated setup, or otherwise repetitive code. If 2 tests are identical, one of them should be deleted. When you go through this entire process, ensuring a test can fail, making it pass, and then refactoring, you're performing what's called the red-green refactor cycle. This is central to test-driven development, which we'll cover in detail in a later video. For now, just remember red-green refactor as the 3 criteria that are required for a test to be useful. Alright, that's enough for theory. It's time to put what you've learned into action. In the demo, we'll add a new test target, use @testable import to import the app target, and write some initial tests. Let's take a closer look at the application we'll be working with. This is a stack review app running in an iPhone simulator. When you click on the Pancake Houses button, it presents a list of pancake houses for you to choose from. Selecting a pancake house shows you details about it. Currently, this app doesn't have any unit tests. That's what we'll be doing in this demo. Let's go over to the code. I've got the Pancake House Collection class selected here. This is the heart of the application. Before we go in depth in the class though, I want to show you just basically an interface view of it. Go to Navigate and then jump to Generated Interface. And this is going to give you something that's similar to a header. It's only going to show the internal and public properties and methods, and is not going to show any of the implementation code. So this is useful in just sort of getting a glimpse at the structure of the class. What we're most interested in is this count property, which gives us a count of the total pancake houses in the collection. We can also subscript the collection to get a specific pancake house at an index. And then lastly, there's this two pairs of methods for loading pancake houses. The production app uses this load default pancake houses, but we're most interested in this load pancake houses via plist name and a bundle. We can use this in our tests in order to use pancake houses that have very specific, test data and allow us to know what they are in advance. Before we can write tests, we actually need to create a new target. So let's do that. Click on the Stack Review project, and then you'll see this plus icon here. You want to make sure iOS is selected, and also the filter. Search for iOS unit, and you should see iOS unit testing bundle. Stack Review Tests is the name that you want, so just go ahead and click Finish. As you can see, this is adding a new target right here, and it's also added a brand new group in the project navigator. Go and expand that. We actually don't want this default file that's created for us, so we're just going to delete that. To keep things tidy, we're also going to create a few groups as well. We'll do this for cases, data, and supporting files. Just move the info plist there, and we'll also sort it by name. This just helps keep this project tidy, so as you continue to add new test cases or new data files, you'll know where to find them in a general sense for the structure. Let's go ahead and add our first test class. So right click, New File, and then you want to look for this unit test case class. By tradition, this is named after the class you'll be testing, followed by the word tests. So we're going to call ours Pancake House Collection Tests. Okay, we won't be writing any Objective-C, so we don't need a bridging header. Let's just get rid of this boilerplate stuff. We won't really need any of it. In order to get access to the Stack Review module, we need to first import it. As we talked about in the slides, this is done using the @testable statement so that we can get access to both the internal along with the public properties and methods. Okay, the next thing we want to do is create a property that will hold onto the instance of the collection we'll be writing tests for. Just call this collection, and then it is important that you declare the type and say that it's force unwrapped. The reason is we want to be able to set this within our test methods, and we don't want to have any side effects, so each test method will get a new instance of the Pancake House collection. For our first test, we want to verify that the collection has the expected count for the pancake houses. Right now, the Pancake House collection is using the production pancake houses. We need to be able to inject the pancake houses that we want to use for the test data. Fortunately, I've already created a test plist for you to use. So just go to wherever you've downloaded this project and drag and drop that test plist in. We'll just put this in the data group, and you don't need the copy items if needed. That doesn't need to be checked. So go and uncheck it. then click Finish. Okay, now we can actually write our first test. We'll just call this one Test Collection Has Expected Items Count. The first thing we need to do is actually instantiate this collection property, followed by loading the Pancake House test plist that we just pulled in. This is a useful trick that you can actually use within your own unit tests, is to pull in whatever sort of test file you want to load, and then you can grab the bundle just by referring to the test class itself as the for. Now we want to write the first assertion statement. As you can see, there's actually several different options we can choose from. The simplest one is this xct assert, which takes an expression that should evaluate to a Boolean. We'll just use this to start. Oh, but wait, we actually don't know what the count is yet. We want to take a look at this plist here. So one useful thing you can actually do is open files side by side. You can do this by holding down Option and then left clicking on this plist here, and it'll bring it up in the assistant editor. Okay, so we actually see that this has 3 items. So we'll just assert that the count is 3. This method also takes an optional message, which is a string that you can specify in the event that it fails. We're going to go ahead and add this too, just to show how that's done. This all looks good, but we would actually expect that this assertion would actually pass. We want to make sure that it will fail, as we want to follow the red-green refactor that we talked about to ensure that this is actually a useful test. There's several things we could do. Let's just go ahead and copy one of these items, and that changes the count, so we would expect that this should fail now. We can run all of the unit tests by either going to this here, holding it down and clicking Test, or you can do Command U. Good, so we've got the failed test. So we've shown that this test here can actually fail. So the red stage is satisfied. Let's go ahead and make it pass. So we'll delete this item. If we just want to run this individual test, you can also come over to this diamond here and click it, and it will just run that one test itself. Let's do that. Great, so we've satisfied the green stage, the pass. The next thing we want to do is see if there's anything to refactor. Since we only have just one single test method right now, there really isn't much that we can do as far as refactoring. So we're just going to go ahead and move on. For our next test, we want to assert that the first pancake house has the expected values. So let's just go ahead and look at that. We'll expand each one of these items. As you can see, this is set up pretty nice to make this easy to test. So the name, for the first one is just name 1, the name for the second is name 2, and so forth, along with the details and others. This is something you can do to make it easy on yourself, and something that I actually do recommend here. So we're just going to write another test that will actually have a few assertions in it. In your own test, you can either choose to write one single test for, the name has an expected value, the details have an expected value, or you can group them together. Really, it is a preference thing. For time's sake, we're just going to group them together in one method, but it really is up to you and really is up to whatever your use case is. Okay, we do need to get the collection and then load the plist again here. So in order to do that, we're just going to go ahead and copy and paste these. This is going to result in redundant code, but we will fix this later on when we get to the refactor stage. Now we're going to use that subscript on the collection in order to grab just the first pancake house. Okay, and we can go into writing our assertions. This time, instead of using the simple xct assert, we're going to use xct assert equals. Under the hood, these basically do the same thing. However, since we are, comparing two values, it's typically common practice to prefer this xct assert equals just because it reads a little bit nicer. So let's just write a few assertions here. We'll write one for the name, the details, and also the image name, which is actually called photo on the pancake house. You may be surprised by this last assertion. Essentially, the XET assert equals accepts any two things that are equatable, including optional values. So if it is nil and the other side isn't nil, it will fail. Otherwise, it takes care of unwrapping it. So this is a nice convenience that it provides for you. Right now, we actually expect this to pass. So let's just go ahead and change the values over here to make it fail. Again, we want to make sure that this test itself can fail in order to satisfy the first stage, which is the red of the red-green refactor. We expect that this should now fail, so let's go ahead and run all of the tests. Great, so that takes care of the red phase. Let's go on to the green phase and make this pass. We'll just revert the changes we made. And run the tests again. And we've passed this test. So we satisfied the green phase. Next, we have the refactor. Since we actually did copy and paste code, we know that there is duplicate code here. You might be tempted to write some sort of internal method that each one of these tests would call. In this case here, this is actually a really good use case for the setup method that XET test case provides for you. The setup method, like we talked about in the slides, is called before each one of these tests is called itself. So each test will get a brand new instance of the collection. And again, this is to minimize any sort of side effects that the tests may have. We don't want one test to cause another test to either fail or pass. We want to try to keep them as independent from each other as possible. We can just delete it from this second test. Okay, and it's also important that you call the super implementation of setup. The XE test case setup method, it really doesn't do much, but in case you ever do subclass XE test case, it's likely that you may want to override the setup method, so it's good practice to go ahead and call the super implementation just every single time you write setup. Okay, when we're refactoring, we want to go from green to green, so we want all of these tests to actually pass. Let's go ahead and run all of them again. Looks good. Now, for our final two tests, we actually want to check the second pancake house and then the third pancake house and verify they also have the expected values. Well, we could go ahead and copy this code and paste it into two new methods, changing the values. This would basically create duplicate code right off the bat, requiring us to refactor. Instead, we can be a little bit more smart about this and create ourselves a helper method that will do assertions, passing in an index for the pancake house. We'll just call this verify pancake house as expected values. And we can start by just cutting and pasting this code, then updating it as necessary. Now, as you can see, the plist is indexed based on 0, but the values are actually based on, +1. So we're going to need another helper value to help us there. Let's just call it plist index. And we'll use that within each one of these asserts. Okay, since this method doesn't begin with the word test, this won't automatically be called by the test runner. But this is actually exactly what we want. We want to be able to call this within our individual test methods themselves. Let's go ahead and do that for this first one. Now we're still in the refactoring phase, so again we want to go from green to green. So let's just run all of the tests, and we expect all of them to still continue to pass. Great. Now the next two tests are actually really easy. We can just copy and paste this test and update the method name signature along with the index. All right, let's run everything, and we expect all of these to pass. Technically, we actually did cheat a little bit with these last two tests in that we shortcutted the red-green refactor process. But already, we know that these can fail because we verified they could whenever we wrote, this first block of code by changing the values. We know that they can pass because they can pass. And as far as refactoring goes, you might be tempted to, maybe pull this out into a single test method and perhaps use a for loop instead. While you could do this, I actually generally recommend against it. The reason why is it's difficult to tell which index failed if you put them in a single test method with a for loop. Here, whenever one of these fails, perhaps the deserialization for the pancake houses is incorrect or something, and is only happening in certain cases for certain values, I'd know which one of these indexes it happened on immediately. So this is pretty useful, and we've also intentionally kept our data set small, just at the 3 items. So all in all, this helps keep the number of methods we have to write to a small number, and it works pretty well. That's it for the demo. Next, it's challenge time. You've previously learned what makes a test useful. You'll next learn what the 3 basic parts of every test are: given, when, and then. For practice by yourself, you'll write a few more tests, which will validate that a pancake house can be added and removed. I hope you've enjoyed this video tutorial. Thanks for watching, and I'll see you in the next video.